Welcome to Practical AI, everybody. My name is Jeff. I'm with Peter Lynn. This is season 2, and we are sponsored by Poqet AI. Poqet AI is a tool used to perform surgery on your models to make them better. While everyone today is talking about RAG and refinement, Poqet AI allows you to edit the weights of your model directly. Peter, we're in the middle of a series called Training Your Own Model, and we are demoing bits and pieces of Poqet AI's tool. And the topic today is accuracy and loss. So what is accuracy and loss? Why is it important? And what are you able to do in regards to accuracy and loss in Poqet AI that you might not be able to do in other tools?
Yeah, so before I jump in, so accuracy and loss is that's the metric that an engineer looks at when they want to decide, is this model good enough to use? So accuracy is really just how many good predictions did it get over the whole entire data set during the training. Once the training's done, usually you then test against the test data set, which is completely separate. And so then you get the accuracy of the training data and the accuracy of the test data. And as you have multiple iterations over both of them, you start to hopefully you see it improve in accuracy, and hopefully you see the loss, which is how many incorrect predictions it got, decrease. So ideally, you want accuracy to go up and loss to go down. So I'm going to share my screen.
And is there always a proportionate number of accuracy and loss values? Like if you have more accuracy, will you have less loss? Or is that not always the case?
It's not always, I mean, gens generally speaking, when accuracy goes up, the loss should also decrease, but that's not always true.
Okay.
So let's look at an example here. Here I have a training run that I did. It was for 40 epochs. And as we can see, initially when it started, so there's 4 lines here. The loss is kind of in the red shade, and the accuracy is in this green shade. So the training data set is the light green, and the test data set is the dark green. So we see at the beginning here that really at the first time it went through the training, the accuracy was around 32%, so less than half. And the loss was way up here. It was at 181. And over time, the loss for the training data set started to decrease. And the lowest that it got was like around, it looks like less than 10%. If we look at the accuracy for the training, we see it kind of also peaked around the same, which is looks like around 95%, but then it kind of decreased in performance and it plateaued. So as you can see the line there, kind of plateaued. And so that's the data it trained on. We look at the test data, which is data the training model has never seen. We're just using it to validate how good or bad the model is. It's in the dark line. So the test loss started out at a lower point, which makes sense because it's done after we've done one run through the training data. And so there, the loss was less, right? So it was 137 versus 181. And then if we look at the test accuracy, it was at 51. All right. And so here we see the dark line. It also plateaus, but it plateaus much sooner in the training data. And this is a very common pattern where the model improves over time, gets better and better and better. And at some point, usually, the accuracy for the test data set plateaus and it never improves beyond that. It just gets stuck. But the interesting thing is actually the loss on the test data set, right? So the loss, we see it started high, it got better, and at some point around, looks like 8 or 10, it crossed over, it intersected with the accuracy, but then we see it's kind of erratic behavior here, right? It goes up and down, and then around 20, accuracy stayed the same, but the loss kind of went haywire.
So explain like how that might happen. Like
Uh,
what might as you're making sense, you're using Pocket AI here to visualize this. How do you make sense of that, or what problem solving or critical thinking do you apply to that?
right. So when most engineers look at this, most machine learning engineers, right, the thing you want to ask is why is the loss going haywire after a certain point? And most of the tools out there don't really give you enough information to figure out like why did this happen? Why did this crazy spiky thing happen after epoch 20? And so that's one of the limitations of accuracy and loss in terms of debugging because it doesn't actually give you enough information to figure out why this thing here is happening. All right. And so the reason Pocket AI came to existence is I got frustrated with this because you can stare at this for days or months or even weeks and be like, well, I don't know why this happened. It's only when you start digging into the actual details that you realize, oh, okay, let's look at epoch 20. And so now you can start to see the patterns that are hidden in your model. And this is why standard accuracy and loss is not very useful for debugging. In fact, it hides a lot of the details, right? Because if we go back to this picture, this doesn't tell me anything useful. Whereas here, I can come in and look, okay, well, if we go to 20, we see, okay, there's certain classes of images that never got any better. So for example, here we got deer and we have it looks like frog never improved and it kept just doing nothing. It never got better than like 25% accuracy. And so this is what's contributing to that spiky behavior that we saw in the regular accuracy and loss. Um, and we can also
Just
then
of like a lot of epochs, like 31 there, where there's like some of the things are kind of crashing
yeah,
together.
yep, right here we see this. So that the triangle blue is horse. So horse was good around 28, but then at 31 it crashed. It went down, right? And
All
so then
right.
this correlates to that weird spike in the accuracy loss for all the classes.
And so you would use this to find patterns then,
Yep.
which visually right now, and then you would then apply the edit method to remedy this somehow. So just explain really at a high level how you would use this visualized data, find patterns, and then fix it.
So the key thing to look for is why is the model getting certain classes more accurately than others throughout the training, right? So you want to look for where did it get good accuracy and where did it have bad accuracy? And we can look to see like, and also, are there classes that are doing the same thing? So like we can see this dark blue, light blue, and purple all went down between 28 and 31. So clearly there are some weights that affected all three classes, right? And so what we want to do is we want to look for patterns like this and then look for the opposite, where a lot of the classes improved. And so now once we see that pattern, we can take the average of two epochs that had the same pattern. So basically two bad performing epochs. We can find two that are good performing epochs, calculate the average, and then when we compare the two, we can identify exactly which weights are contributing to a decrease in performance for all those classes.
And then what would you do with those weights once you've identified them?
But once you've identified it, you can adjust them.
And you should see that pattern go out. Now, can you do without even addressing the weights? Could you do something just with the data set here? You said you got frog and was it bird or truck that's just not performing,
Yep.
you maybe pump more of those records in to just give it more time to train? Or how can you adjust the data set?
So you could. So that leads to kind of other questions. For example, one problem with refinement is if you take your model, so let's say you've trained a model, and now someone says, hey, I want you to improve this model, but handle these three new classes. But what tends to happen is the model will learn for those three new classes. And if you don't include the original data set, it'll crash on on the original set of classes. So in other words, the model will actually forget all the previous classes. And so that's why when people are improving models, they always just add data, they don't remove data.
Hmm. Well, this is good. This is a good sort of high level on accuracy and loss and how you're using Pocket AI to leverage what you're seeing, find patterns, then use the edit method to actually edit the weights and improve the model. Very
Yeah.
good, Peter. Thanks for the demo. And we will hit up some of the charts, maybe diffs and patterns, short circuiting, or some other topics we might hit next time. Take care, everybody.